Today, I would like to present our comprehensive cloud architectural solution for XYZ University record system. In the following slides, we will examine each architectural layer in details, from network infrastructure to IoT integration, demonstrating how this solution meets all functional and compliance requirements. For that, currently system faces challenges during peak administration period with slow response times. Our AWS-based solution achieves 19.9% availability by compiling with FERP and GDPR regulations through robots incubation. For the business requirement, we can see business must support 5,000 plus concurrent user at a peak time, but the system must process CRD operations transactionally while maintaining 500 milliseconds search performance across 100,000 records. Our RBS implementation feature distinct permission tiers such as students get read-only access to their profile, faculty have course-specific return access.
Hi, I'm Santos and I'm here to present about functional requirements. Three IoT channels automate previously manual processes. Biometric terminals using Supreme scanners capture attendance via a AWS IoT core with Lambda processing data into RDS. RFID readers track campus movements through green grass age devices, while Feature Scan Snap Station leverage Amazon TextRAT for document processing. The system triggers validation workflows during record updates while preventing post-deadline grade changes and notifies stakeholders through SNS alerts. These features collectively reduce manual data entry by 90% while improving accuracy through automated validation check at each processing stage. Now let's move on to the next slide into network layer architecture. Our network design begins with Route 53's geological routing reduce international latency while DNSS is EC prevents spoofing attacks. CloudFront's 216 is location CDN solves static access with 1 year caching. File names enable cache busting, while dynamic content use 1 second caching with origin shielding. Sensitive documents employ signed URLs with 5-minute expiration. The BPS architecture enforces strict segments, public subnet only for ALB NAT gateways, private subnets across three edges for application with isolated database subnet with no internet routing. Security groups implement zero trust principle with microsegments. Now let's move on to the next slide into compute layer architecture. While looking into compute layer architecture, the ALB distribute traffic using least outstanding request algorithm while cross-zone balancing ensuring event disturbance regarding of instant payment for placement, host-based routing directs API calls to delegate targets groups within 15-minute sticky session, maintain stake for file upload workflows. Our auto-scaling configuration combines predictive scaling, analyzing 14-day cloud watch metrics with target tracking, maintaining 60% CPU and step scaling, adding 4 instances with latency exceeds 800 millisecond. The instant mix optimized cost performance. M6i large for the web servers, C6 dot X large for the API tier, and 30% sport instance for stateless background workers. Now, the other slide will be presented by my team member, Ruth.
Hello, I'm Ruthvi. Um, so now moving to the next slide, like the data layer architecture. So in this slide, Aurora PostgreSQL forms our data backbone with five read replicates distribute across regions, handling analytical queries without impacting transactions. So serverless V2 auto scaling adjusts from 2 to 64 ACUs based on demand, while backtracking enables 72 hours rewind capability for recovery. So the global database maintained less than 1 second replication lag for DR scenarios. So S3 intelligent tiring automatically transits objects active, document in frequent access, archives moving to infrequent access after 30 days, and compliance records in Glacier's instant retrieval. Data lifecycle policies ensures cost-efficient storage without compromising accessibility. So now moving to the next slide, which is security architecture. So in this slide, attribute-based access control, which is called ABAS, grants permits through department classification environment tags rather than individual IAM policies. So AWS Shield Advanced provides DDoS protection with TLS termination at ALBs using perfect forward secretary for ciphers. So Secrets Manager automatically rotates credential every 90 days, while Messi continuously scans S3 buckets for P2 with automated remediations workflows. Now, AWF rules at the ALB filters SQL injection and XSS attempts before reaching EC2 instance. ACLs supplements security groups with explicit deny rules for non-malicious IP ranges. So moving to the next slide, which is operational excellence. So our CI and CD pipeline integrates GitHub commits, triggering code build jobs that runs unit test and vulnerability scan using Amazon Inspector. So Canary deploys initially route 5% traffic to new versions with CloudWatch synthetics, executing test workflows every 5 minutes, simulating student login ID, grade view, transcript, download sequences, and etc. So now blue and green deployments use Route 5.3 weighted routing for seamless transitions. Uh, Chaos engineering test via fault injection simulator validate failure recovery procedures, while service squads monitor resource utilization against account limits. Now, my another team member will represent the rest of the presentation. Thank
The IoT device ecosystem includes Suprema Biomini 2 fingerprint scanners, Impinj R420 RFID readers, and Fujitsu Scan Snap scanners, all secured with IoT device defender agents. Uh, the rule engine validates device timestamps to prevent tampering, transforms RFID codes to student IDs, and routes data to Kines for real time dashboards. Can we move to the next slide, please? The next, please. Here is the challenges and mitigations. So data consistency challenges are basically addressed through DynamoDB transactions with compensating transaction patterns for rollback.